So in this video, we are going to continue on with our previous lecture on LeChatelier's principle. So in the last video, we talked about what is LeChatelier's principle. If a system at equilibrium is stressed, it will shift in order to reduce that stress. We also talked about how concentration and pressure can stress a reaction. So today we're going to talk about a few more factors, first of which is temperature. So let's say we increase temperature. If the temperature of a system is increased, the system shifts to consume the heat. Think of this like what happens if you get warm. If you get warm, your body wants to cool itself down, so it might start sweating in order to cool you down. We are in homeostasis. We want to have that equilibrium temperature. If our temperature goes up, or if you get sick, you get a fever, that temperature is increasing, your body wants to decrease that temperature. Our system at equilibrium works the same way. If the temperature is increased, we want to get rid of that heat. And then just the opposite, if the temperature of a system is decreased, well, temperature goes down. How do we reduce stress? We want to produce more heat. The system shifts to produce heat. All right, there's one more thing that you have to know. Unit 9 is on thermochemistry, so we haven't talked about some of these terms yet. So very brief introduction into two terms that you need to know. First being endothermic. If something is endothermic, if I have an endothermic reaction, it means it's heat absorbing. Endo means like in, so it's absorbing the heat or taking the heat in. If I have an endothermic reaction, delta H is going to be positive. Delta H stands for enthalpy. Again, we'll talk about that more next unit. For now, just know if delta H is positive, it's endothermic. Well, why does this matter? If a reaction is endothermic, it's taking heat in, we are going to think of heat like a reactant. That means that heat is going to be on the left-hand side of the arrow with the reactants. So if it's endothermic, it's heat absorbing, it takes heat in. Heat is on the left-hand side of the reaction. Some reactions are exothermic. Think of exo like exiting. We're exiting that heat, or heat is being released. Exothermics are heat releasing. We can identify an exothermic reaction because delta H would be negative. Well, now if a reaction is releasing heat, we can think of heat like a product. So this will be very, very important to keep in mind because you need to know what side of the reaction heat is going to be on. So let's say I gave you this reaction, N2O4 U8.A2, and I told you that delta H was a positive 58.0 kilojoules. And I want to know what happens when I decrease temperature. Well, the first thing that I want you guys to do is look at delta H, decide is it endothermic or exothermic. So delta H is positive. That means it is endothermic. If it's endothermic, we're going to think of heat like a reactant. So write heat on the appropriate side. That's going to help you visualize what happens. So now I decrease temperature. Well, the way that we reduce that stress is to increase the temperature. So the system shifts to produce heat. If I want to produce more heat, it's going to shift to the side that heat is on. So equilibrium shifts left. Do you remember that little saying that we had for concentration? When you add, it shifts away. When you subtract, it stays. You could use that same saying for temperature. If I decrease temperature or I'm subtracting heat, equilibrium stays on the side that heat is on. So it's going to shift to the left because heat is on the left. If I were to add heat, it's going to shift away. All right, let's look at another example. All right, let's say this was my reaction. And this time I told you that it's exothermic. So I know that heat is on the right-hand side. Increasing temperature shifts equilibrium. Blank. Concentration of ammonia increases or decreases, and the concentration NO increases or decreases. All right, so I have heat over here on the right-hand side. If I increase the temperature, the way we restore equilibrium is by consuming that heat. I want to use heat up. So it's going to shift to the side that heat is not on. It is going to shift to the left. We could also use our saying, if you add, it shifts away. If you subtract, it stays. Heat is on the right. If I add it, it shifts away. It goes to the left. So now I know equilibrium is going to the left. That means everything over here is getting consumed or used up. So concentration of NO decreases. Everything over here is getting produced. It's the reverse reaction, shifting to the left, so NH3 increases. Next, let's talk about catalysts. So we talked about catalysts when we talked about kinetics. We know that catalysts increase the rate of reaction. by lowering the activation energy. So quick reminder from our module on kinetics. Adding a catalyst will lower the activation energy. And that's why the reaction goes faster. Well, what happens if we add a catalyst to a reversible reaction? Well, it's going to lower the activation energy for both the forward and reverse reactions. So what does that mean? Well, it's going to increase the rate of both reactions. That means it increases the rate at which equilibrium is reached, but it does not shift equilibrium. It does not shift equilibrium. So there's two ways to have no shift. First is with pressure. If we have an equal number of moles of gas, it's not going to shift equilibrium. The other way to have no shift is by adding a catalyst. So let's look at just a really rough sketch here. So let's say we had time versus concentration. So let's say here's my reaction without a catalyst. So right maybe about here, we reach equilibrium. Concentration is no longer changing with time. So what happens if we now add a catalyst? It's going to reach equilibrium much quicker. So blue represents with the catalyst. So notice that it gets to equilibrium at a much quicker time, but equilibrium stays the same. It's not going to shift equilibrium. Beware of catalyst. These are trick questions. So if I asked you on an exam, I add a catalyst to this reaction, which way does equilibrium shift? Your answer would be no shift. Don't get tricked by that. All right, lastly, let's talk about external ions. External ions are going to be ions that are not part of the reaction. So what we're going to do is look for ions that want to bond. So usually we're looking for a cation and an anion, and usually they're going to have the same magnitude of charge. So what is going to happen is the concentration of that ion will decrease. If we add an external ion, the concentration of that ion that it wants to bond to will decrease. Let's look at the example. Alright, so here is my reaction. And let's say we wanted to know what happens when I add silver ions. Adding Ag plus will shift equilibrium in which direction? Alright, so we are going to answer this question, but we're going to talk about what happens first. So we want to look for ions that want to bond. So silver has a charge of +1. So knowing that silver is a cation with a charge of +1, what is the most likely ion that it's going to bond with? Cl-1. And in the process, it's going to produce silver chloride. So I add silver. It's an external ion because silver is not part of the reaction. When I add silver, it's going to start bonding up all the chloride to produce silver chloride. So what's happening to the concentration of chloride? Well, the concentration of that ion will decrease. Because it's getting used up as silver chloride is produced. So we add silver to this reaction. Silver is going to come in and start bonding up all the chloride ions to make silver chloride. So if silver starts bonding up all of the chloride, that means the concentration of chloride decreases. So this is the key fact that we need in order to figure out which way equilibrium will shift. Concentration of chloride will decrease. So how do I make more chloride? It needs to shift to the side where chloride is being produced. So equilibrium shifts left to produce more chloride. Again, you can use our little saying, if you add, it shifts away, if you subtract, it stays. If the concentration of chloride is decreasing, it's like we're subtracting it, equilibrium will stay on the side that chlorine is on, chloride is on the left-hand side, so equilibrium shifts